Good morning, everyone. I am here again for my course Aircraft Systems. This course is designed for the 6th semester Aeronautical student of Institute of Aeronautical Engineering, Hyderabad. Today my topic is power actuated system, engine control system, push-pull rod system, flexible push-pull rod system, control linkages. I am Dr. Yagya Dutta Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. So I'm going to discuss about different types of flight control systems which are used in the aircraft. So I will talk about the conventional system, direct mechanical control. This type of system were used on the olden aircraft or very small aircrafts. Still, these things are used. The linkage from cabin to control surfaces can be fully mechanical if the aircraft size and the flight envelope is low. Okay, if you see here, this is small, so it is like a mechanical system. From here, it goes to the all type of controls. So it is, if the aircraft is very small, we can use like this. In this case, the hinge moment generated by the surface deflection is low, enough to easily contrasted by the muscular effort of the pilot. Two types of mechanical systems are used, that is push-pull rod and the cable-pulley. So here we have push-pull rod one type and the cable and the pulley is another type of systems we have to use. In the first case, a sequence of rod link the control surfaces to the cabin input are used. Bell crank levers are used to change the direction of the rod routing. This sketch is showing the push-pull control rod system between the elevator and the cabin control of the system. So it is a push-pull rod. We are not using any cable and the pulley, only rods are there and these things are operating the elevator. Bell crank lever. The bell crank lever is necessary to alter the direction of the transmission and to obtain the conventional coupling between stick moment and the elevator deflection. Vibration on the control rod. A model analysis of the system layout is necessary because vibration of the rods can introduce oscillating deflection of the surface. This problem is important on helicopters because vibration generated by the main rotor can induce several resonance of the flight control rods. Especially in helicopter, a lot of vibration due to the motion of the blade, and the tail rotor is also, so every part is moving and they are rotating. So these helicopters are generating a huge amount of vibration, and this vibration are transferred in the control stick. So your hand, your body will be shaking like this. So that time it is very important. Advantage of cable and the pulley system. The same operation described can be done by a cable and the pulley system. Just now I have discussed about the push-pull rod, but same things we can do by the cable and the pulley. The same operation describes can be done by a cable and the pulley system, where couples of cables are used in place of the rods. In this case, pulleys are used to alter the direction of the lines, equipped with idlers to reduce any slack due to structure elasticity, cable strand relaxation or thermal expansion. Often the cable pulley solution is preferred because it is more flexible and allowing reaching more remote area of the airplane. The example is shown in the figure where the cabin column is linked via rod to a quadrant which the cables are connected to. For this reason, the actuation system in charge of the primary control has a high redundancy and the reliability and is capable of operating close to full performance even after one or more failure. This you can see here that how these things are working. It is a push-pull rod, and if you see here, it is a cable and the pulley system, mechanical flight control system. Here it is shown for the elevator. This is the elevator here. This elevator, and this is your horn. Here we have the pulleys. These are the pulleys, And here we have, this is the cable. Okay, this and this, they are the cable, these are the pulleys, and they are called the control stick or the control rod. And here is the bearings. Everywhere these bearings are attached. This is called the push rod, and this is the jointly cable and the pulley and the push pull rod, both are used in this system. The most basic flight control system designs are mechanical and date back to early aircraft. They operate with a collection of mechanical parts such as rods, cables, pulleys, and sometimes chains to transmit the forces of the flight deck control to the control surfaces. Mechanical flight control systems are still used today in small general and sport category aircraft where the aerodynamic forces are not excessive. When the pilot pushes the control stick forward, backward, the cable is getting tensed through the linkage and is cause the control surface to move. Okay, just you can see here, if you move this rod here, then this will go this side, and this cable will go this side, this will go this side, this will move this thing here, and this thing will be deflected down. So if you deflect down, it will go, forces will go upward. Okay, so like this, your systems are working in a mechanical flight control system. After mechanical, then power actuated, the hydraulic systems are used. So in this, we have used the hydraulic control system. When the pilot action is not directly sufficient for actuating the control, the main option is to powered system that assist the pilot. A few control surfaces on board are operated by electrical motors. The valve that is located near the actuators can be signaled into two different ways, mechanical or electrical. Mechanical signaling is obtained by push-pull rods or more commonly by cables and the pulleys. Electrically signaling is a solution of more modern and sophisticated vehicle. The hydraulic system has proved to be the more suitable solution for actuation in terms of reliability, safety, weight per unit power and flexibility. With respect to the electrical system, which is becoming the common tendency on most modern airplane, the pilot via the cabin component sends a signal or command to the valve that opens port through which high pressure hydraulic fluid flow and operates one or more actuators. Basic principles of the hydraulic control system, it is depicted here. Two aspects must be noticed when the powered control is produced or introduced. The system must control the surface in a proportional way. That is, the surface response, that is deflection, must be a function of the pilot demand or stick deflect. How much pilot is deflecting, that much only control should move. The pilot with the little effort act on a control valve must have a feedback on the maneuvering intensity. The problem is solved by using hydraulic servo mechanism where the components are linked in hydraulic circuit in such a way to introduce an actuator stroke proportional to the pilot demand for a correct operation. In both cases, the control valve housing is integral with the cylinder and the cabin column has a mechanical linkage to drive the valve. These things are shown here, that how if you put this control, this will move and this will also move as per that. In the first case, the cylinder is hinged to the aircraft, and due to the valve spool displacement and ports opening, the piston is moved in one direction or the other. The piston rod is also linked to the valve spool stick in such a way that the piston movement brings the spool back towards its neutral position. When this is reached, the actuator stops. In the second case, the piston is constrained to the aircraft. The cabin column control the valve spool stick. This will result in a movement of the cylinder, and this brings the valve housing again towards the valve neutral position, then resulting in a stroke proportional to the pilot's demand. In these basic principles of hydraulic control, this we can see here that there must be two aspects must be noticed when powered control is introduced. The system must control the surface in a proportional way. That is, the surface response, the deflection must be function of the pilot's demand. That is stick deflection, for instance. Means how much you are able to deflect the stick. In the same proportional, your control should move. Your control should move in the same ratio. That is, the pilot with little effort act on a control valve must have a feedback on the maneuvering intensity. The next thing, as and when the pilot is giving some signal or the pilot is giving some input, the aircraft should behave like that. Aircraft should respond accordingly. So that is the second case. The problem is solved by using hydraulic. This problem of pilot is putting very hard work. This is solved by using hydraulic servo mechanism, where the components are linked in a hydraulic circuit in such a way to introduce an actuator stroke proportional to the pilot demand for a correct operation. In both cases, the pilot valve housing is integrated with the cylinder and the cabin column has a mechanical linkage to drive the valve. In the first case, the cylinder is hinged to the aircraft, and due to valve spool displacement and ports opening, the piston is moved in one direction or the other. The piston rod is also linked to the valve spool stick in such a way that the piston movement brings the spool back towards its neutral position. When this is reached, the actuator stops. In the second case, the piston is constrained to the aircraft. The cabin column controls the valve spool stick. This will result in a movement of the cylinder, and this brings the valve housing again towards the valve neutral position, then resulting in a stroke proportional to the pilot demand. So this we can, what are the components required for any hydraulic system? So for any hydraulic system, we need one reservoir. From this reservoir, there will be inlet. This is the return line, and this is the outline, and there will be a pump. From the pump, there will be filter, there will be NRV, filter, this is the pump, this is hydraulic pump, filter, NRV. Then you will get here actuator, different actuators, then selector valve. Okay, so from here it may go. This is the return line. Here your control surfaces are attached with some link. These are the control surfaces. These control surfaces may be elevator, aileron, or rudder. They are called the primary control. But there are few more, that is called the slat, flaps, spoilers, canard. These are the canard will come here. These are the secondary. Secondary control. These are very much essential for any control, that this should move accordingly. So these are the few components which are used for this type of systems. So what is the need of the control system? Need of flight control systems. You see, if we have an aircraft, this is the aircraft, this is the CG, this is the x-axis, and these are the wing, these are the, okay, so this is the y and this is the z. Okay, I have shown this thing before. This is the roll axis, this is the yaw axis, and this is the pitch axis. So to have the aircraft properly controlled, your aircraft should move in a different axis or the different configuration. Then we have to make sure that aircraft is working in the same as we require. So to have nose up, what we have to do? If I want to make your aircraft flying like this and I want to make nose up, so this is the CG. I have here elevator. This is called elevator. Here we have the ailerons. And here we have the rudder. And these are the moving parts. So I am putting the hinges here. Here also you have the ailerons. And here you have the flaps. These are the flaps. Okay, so if I want to make nose up, then what I have to do? If I want to make this nose should go up, so I have to make here elevator also up. So if I make the elevator up, then the force will act in this direction. A lift force will act downwards. This downward will make up like this. Nose will go up. Opposite will happen. So you can see that if you want to make nose up, your elevator should go up. If you want to make nose down, elevator should go down. So to make elevator down, this lift force should act in this direction. This lift force should act in this direction and your aircraft will move accordingly. Now if I want to make yaw, just I will show the yaw motion. Yaw motion and control. Okay, how this yaw motion is done? Yaw motion means with respect to z axis, means vertical axis, your aircraft is nose is going up and down. So how it is happening? It is happening by the help of rudder. This is the aircraft. Just I am showing only the rudder, not showing other things. And this is the CG here. This is the X, this is the Y, and this is the Z. So when the motion is happening with respect to the vertical axis or the yaw axis, it is called the yawing. In this, nose will go left or the right. This will happen if you want to make nose right towards this. Nose has to go right. So I need a force in this direction. So this force, it is called the side force. This side force should generate opposite to this. So I have to put in the same direction in this. If I want to make nose towards the right, I have to deflect towards the right. So what will happen? This angle will increase and the lift force will act in this direction. nose will go right. So in this way, if I want nose right, your rudders should go right. A force will act in this direction. So in this way, and if I want to make left yaw, what I have to do? Then I have to make this is your rudder, and I want to make towards the left. Okay, then what I have to do? I have to turn this thing towards the left like this. So here, like this, angle of attack in this direction will increase. Your lift force will act in this direction. The force will act in the direction of Y, and this will pull like this. Your nose will go like this because CG is here. This is a CG. So like this, you will get the yaw. So I have explained about the yaw, and also I have explained about the pitching. Pitching is done by the elevator, and yawing is done by rudder. I think this is clear now. Now I will discuss about the yaw motion. This about rolling motion. Rolling motion and control. So if I am flying like this aircraft and I want to roll like this, I want to roll like this. If I want to make this is the right side, I want to make a right side like this. So the left side wing should have more lift. Right side will have less lift. So I am just showing as a wing, first, this is the wing. This is the right side, and this is the left side. Aircraft is forward motion. So aircraft is flying like this. I want to make right wing down, rolling right down. So here we have the elevators. These are the ailerons. These are the ailerons. These are also ailerons. And these ailerons are always moving in opposite direction. If I want to make this right wing down, left wing up, so what I have to do? This I have to make down like this. So here angle of attack is increased. So here is additional lift, and here this I have to make upward like this. Upward. So this lift is reducing lift like this. So your rolling will happen towards right. Okay. So in this way, I have explained about all the three primary control surfaces which are used on the aircraft. Any of the aircraft, these primary control surfaces will be there. But we have also some secondary control surfaces. We have some secondary control surfaces like a slat, flaps, spoilers, and so on. So if you see, this is the wing. Slats are some additional aerofoil which are normally attached with the wing here. But as and when we need more aerodynamic forces or more lift, that time this some additional like this will come out. Additional. And this will generate additional surface. additional surface and additional camber. This creates the additional lift. So especially during the takeoff and all, we need more lift. During landing also, we need the more lift. During takeoff, we need more lift, less drag. During landing, we need more lift and the less lift and the less drag, more drag. So accordingly, we have to act and we have to produce the. So this is the slat. Now flaps are fitted at, this is the leading edge of the wing and this is the trailing edge. This is the trailing edge of the wing. So this you can put like this, extended. So here also the surface area is increased and the camber is also increased. So this gives also the same effect as this, but the flaps are used mostly for the landing and the takeoff, but these are only used for the landing, for the takeoff purpose, not for the landing purpose. Okay, so I think these are the these are the references, that aircraft systems, mechanical, electrical and avionics system. And another book is from Design and Development of Aircraft System and Introduction, AIA Educational Series. Thank you very much. If any questions, you are welcome to ask in my mail. You can send me at the gmail.com. You are welcome to ask. Thank you. I will meet you soon, very soon. Please do like this video and subscribe if you feel it is okay. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.